Hello all. In this video, we're going to talk about Module 6.4, Example 5, graphing a cube root function. So similar to our square root function that we graphed in previous examples, a cube root function is a radical function that contains the cube root of a variable expression. So our parent function for these functions is going to be the cube root of x. Our domain and range will both be all real numbers. Our intercepts of our parent function will be x equals 0 and f of x equals 0. Our end behavior, increasing and decreasing, positive and negative, and symmetry will all be as shown in the table here. So what happens when we manipulate the parent function and move it, translate it around the coordinate plane, stretch it, compress it, shift it? So that's what we're going to talk about in this section. So let's jump in with this first example A here. We have g of x equals 1/3 the cube root of x. So we're being asked here to graph each function and identify the domain and range, and then describe the transformation as it is related to the parent function f of x equals the cube root of x. So here we have g of x equals 1/3 the cube root of x. So our domain is going to be all real numbers. Our range is also going to be all real numbers, which we represent with this R that has two main lines there, two vertical lines, I guess. So we're going to graph this function using a table. So we're going to have x and g of x. So if we plug 0 in here, 0 is a perfect cube. So for this particular example, we want to find numbers that are going to give us a perfect cube. That way our math is simple. So if I plug in 0, the cube root of 0 is 0. 1/3 times 0 is 0. So we're going to graph 0, 0. Now, what is a perfect cube? So perfect cubes are numbers that this times this times this 3 times is going to give us that number. So one example of a perfect cube is 27, right? 3 times 3 times 3 is 27. So the cube root of 27 is 3. 3 times 1/3 is 1. So if I put 27 in for x, I'm going to get 1 as g of x. Now, with the cube root, I could also plug in negative 27, because the cube root of negative 27 is negative 3, and negative 3 times 1/3 is negative 1. Now, 27 and negative 27 don't fit on our graph, so we're going to need to come up with something that fits on the graph. So another perfect cube is 1, right? 1 times 1 times 1 is 1. So the cube root of 1 is 1 times 1/3 is 1/3. And the same thing for negative 1. The cube root of negative 1 is negative 1 times 1/3 is negative 1/3. So this at least tells us where we're at here. So if we've got our 0, 0, we know that at 27, so way all the way over here somewhere, we're going to be at 1. So our line is going to be it's going to be approaching 1 as we get larger. So 1/3 is going to be, if we zoom in, 1/3 of the way between 0 and 1. That's 1/3. And then we had negative 1, negative 1/3. So while the graph is within our domain here, which only goes to there, right, we're going to be between -1, and 1, because we have to get all the way to 27 and -27 before we get bigger or smaller than 1 and -1. So we want to plug in numbers that are outside of our domain so that we know how far up or down we're going to go. So we know that while we're on the graph, we're going to be between -1 and 1 for our y value. Now, our transformation here. Here, the only difference between f of x equals the cube root of x and g of x equals 1/3 the cube root of x is our 1/3. So this is a vertical compression of 1/3, and that's our only transformation in this particular scenario. All right, example 5, part B. Again, we need to find our domain and range, which for the cube root is all real numbers and all real numbers. So let's pick some values to plug into p of x. So we want numbers underneath the radical that are going to be perfect cubes. So I know that the cube root of 0 is 0. So I want to plug in something that's going to give me 0 underneath. So if I plug in -5, right? -5 plus 5 is 0. The cube root of 0 is 0. We can take the cube root of 1. So I'll plug in -4 and get 1, because the cube root of 1 is 1. I could also get -1, cube root of -1. So -6 plus 5 is -1. Cube root of -1 is -1. And then another perfect cube is 8. So I'm going to plug in 3 to get 3 plus 5 is 8. The cube root of 8 is 2. So let's graph these. -5, 0 is right here. -4, 1. -6, -1. And 3, 2. That's right here. So I'm going to go something like this with my graph. So we're going to connect the dots with a smooth curve. And with our cube root, we're going to end up with a little kind of S shape. Now our transformation. Here, the only difference between our cube root of x and cube root of x plus 5 is the plus 5 under the radical. So remember, what's under the radical does opposite of what it looks like. So this is going to be 5 units left. 5 units left, because it looks like a plus 5, but h is actually -5. So we're going to shift 5 units left. And that's our only transformation for that one. All right. So letter C here has more than one transformation going on. Go ahead and pause the video now. See if you can find the domain and range, graph a handful of ordered pairs, and then name the transformations for q of x equals the cube root of 4 minus x plus 1. All right, hopefully you at least found the domain and range as all real numbers. And then we plug in some values, which, like our previous examples, we're looking for values that are going to give us perfect cubes underneath the radical. So, if I'm looking for a perfect cube under the radical, I could plug in 4 to get 4 minus 4 is 0. The cube root of 0 is 0 plus 1 is 1. I could also plug in 3. So I get the cube root of 4 minus 3 is 1. The cube root of 1 is 1 plus 1 is 2. I could plug in negative 4. 4 minus negative 4 is 8. And the cube root of 8 is 2. Plus 1 is 3. And I could plug in 5, right? 4 minus 5 is negative 1. The cube root of negative 1 is negative 1. Plus 1 is 0. Let's see what that looks like when we graph it up here. 4, 1. 3, 2. 5, 0. And negative 4, 3. So here, my graph, if I connect the dots with a smooth curve, is going to look something like this. And my transformation. I don't have a stretch or compression because there's nothing in front of my cube root. I am going to shift 4 units to the right, as you can see. The middle of my little S curve here is 4 units to the right of the origin. And I'm also going to go 1 unit up because of my plus 1 here for K. All right. That is the completion of lesson 6.4.